As far as the role of muscle when it comes to weight loss, I love your educational piece here. So let's talk about supporting that lean mass development with whey and specifically with isogenics. And I'd love for especially those new people on the line, if Dr. Colgan, you could do a comparison of that our whey protein compared to other whey proteins on the market.
Oh, sure. Okay. Well, yeah, and when I started investigating this in the 80s, at Rockefeller University, we had an enormous number of different ways that started to come out then, and they were all over the place, and they had all sorts of different structures. So we tried to test. We tested a lot. And I found that the one that I'd been working on in New Zealand before I came to the United States turned out to be the best. And so I set out to find out why it was the best. And I came up with a few things. One was the method of extraction, which was developed by the New Zealand Dairy Board in the 80s, which was a cold cross-flow membrane extraction, which did not denature the protein. Now, most whey that you buy is denatured. That is, it's extracted with heat or acids or salts, which is the easiest extraction method. But in doing so, you break down these essential keys between amino acids called sulfur bonds, and they shape the amino acid into a little key that fits into the gene expression lock in the body and turns on the protein function. Now, we didn't even know, we knew that some of these ways were not working because they were denatured, but we didn't even know this till about 1995 or 96, and it wasn't really accepted till about 2000. But it's absolutely well known now that if you break down the dipeptides and the tripeptides, these little keys, then the protein's not going to work. And one of the things that is important about the isolene and isopro is that it's undenatured. That is, it's extracted and with a cold membrane type of extraction that does not break those bonds. So that's one thing. The second thing, and again, when I was looking for it, we didn't realize it at the time, but around about 82% of all cattle in the United States are fed in what are called confined animal feeding operations. That is a concrete yard in which they are fed essentially what's cheapest legal cattle food that month. It could be corn, it could be pelletized chicken feathers, it could be wheat, it could be hay. And this is an unfortunate development of agribusiness in the United States from the 1950s. And I haven't got time to, to explain all of that, but it really started out with the making of NPK fertilizers, which made it impossible for people to do traditional farming because they were so cheap. And so, but that's a whole other story. But the problem with taking an animal that has evolved for millions of years by eating grass and humus, which is what it lives on, is that it's absolutely unsuited, first to an intermittent diet and second to an acidic diet, which they now get. Because it's called a ruminant, because cows are ruminants. They have a rumen, and a rumen is a brilliantly designed acid-neutral fermentation tank for grass. That's absolutely, it is so miraculous, and yet we try and feed it things like corn, and it doesn't work. And that is really why the cows are only viable for about 5 months, on average 5 months, before they have to have antibiotics. And then in order to get the production of the milk, they have to be given growth hormone. So that's where it all sprang from. And it developed over years and years, and sort of nobody noticed. And then when I went back to New Zealand, I had a look at what they were doing there. And for some reason, the agribusiness that has swept across Europe and certainly across the United States and most of Canada has not happened there, at least not to very much extent. So most of the cows are still range fed, and that's a key thing in the structure of the protein. If you have a range-fed animal, it gets its natural diet. It produces protein with a different amino acid structure and a different structure of immunoglobulins than when you feed it in the wrong way. And so that's a very important point. The nutrition of the cow and the method of extraction of the whey are the two biggest things that separate the isolene and isopro from most of the whey proteins out there.
Mm-hmm. Boy, what an eye-opener. I mean, as you were explaining how 80+% of cattle are handled and what they're fed in order to produce milk to be, used for human consumption, whether it's whey protein or milk in a gallon container, it's pretty grisly, really.
It's scary, yes.
It really is. And this isn't the only area of processing and that we're seeing of major concern in the food chain that we're eating, in the foods that we eat. So again, going back to the inferior food sources, our whey protein is so amazing, and I want to go into the amino acid profile because it's 18 different naturally occurring amino acids, very high in branched chain amino acids. When it comes to those amino acids supporting lean mass development, can you get any better as far as lean mass development fuel?
No, I think probably the best way for me to explain it is for some reason that we don't know. We really don't know why this is, but for some reason the amino acid profile of whey protein concentrate, at least undenatured whey protein concentrate, matches the profile of human tissue. And it's just fortunate it happened that way. I mean, it happens sometimes in nature, but there's I think probably the best way for me to explain it is if you go into sports supplements today, you'll see there's many protein supplements are made of mixes of single crystalline amino acids. And almost all of these, and most people don't know this, are manufactured synthetically from chemicals. They're not made from food in the laboratory. They don't come from protein foods. So there are a lot of differences in chemical structure, and they don't work very well anyway, even though we thought they did in the 1980s and 90s when they first came out. But what we didn't realize then was that most athletes that we were trying to test were on inferior protein nutrition. So mostly what we were doing by supplementing specific amino acid mixes was filling in some of the deficiencies. But unfortunately, of course, it got picked up by commercial interests, and the masses of mixtures of branched chain amino acids and arginine and ornithine and glycine, glutamine and creatine and chemicals that are not even amino acids like taurine, which is a sulfonic acid. But the real problem with them is that protein nutrition, we know now from the 21st century molecular chemistry that's developed, is much more complicated than we thought, much more complicated. And singular amino acids or amino acid mixes made in the laboratory are really one-shot chemicals that have a very limited role. So, I'll just take one example. You were talking about amino acid profiles. Well, Isogenics just recently published my recommendations for athletes in the 1990s from first principles in our lab. we worked out physiologically the requirements of the optimum requirements for an athlete, and it came out to, in our calculations, 1.8 grams per kilogram body weight per day. And then we compared that with actual measurements done on nitrogen balance studies and things like that, and that they came out at 1.7 per day. Now, many of these top sports science organizations have now adopted numbers between 1.7 grams per kilogram body weight per day and 2.4 as being the ideal for an athlete. So that's I think my standard is 1.8, and that's the one that Isogenics published. But if I take it's sort of a complicated example, I'll try and simplify it. But commonly, very common supplement for athletes is glutamine. And commonly they would recommend, the supplement manufacturers recommend 10 pills of 500 milligrams of glutamine a day, which is big pills because they have to have a lot of other synthetic chemicals in them to make the pills. And so that's 5,000 milligrams of glutamine. And you feel like when you take all those pills, it must be doing something. But unfortunately, it's not. If you take correct protein nutrition as I have advised it, and that is with a combination of isoline and isopro for an athlete, it provides at least 18 grams of glutamine a day, plus the things that glutamine's made out of, leucine, isoleucine, and valine, the three branched chain amino acid. It provides 10 grams of leucine, 5 grams of isoleucine, 5 grams of valine a day, and about 40 grams of all the other amino acids. So if you compare that to amino acid pills, there really is no comparison.
Mm-hmm. I love that breakdown. Thank you so much, Dr. Colgan. Well, I could listen to you for a whole nother hour talking on this, but our time is up, and I look forward to having you on in the near future for